Hey everyone, welcome back to Math with Vansh. I'm Vansh and I'll be teaching you math, obviously. So in the last video we looked at some derivatives of inverse functions and how we'd go about solving them. And this video is going to be kind of a continuation of that. So in this video we're going to be looking at the derivative of inverse trig functions. So if you're ready, I am too. Let's get started. Okay, so we're going to be looking at the inverse sine function, inverse cosine function, inverse tangent function. Okay, so let's start with the inverse sine function. So first thing we're going to do is we're going to set y equal to sine inverse of x. And this is just the inverse sine function. And something that we know is that the sine of sine inverse x is just equal to x, right? So we can write, and since sine inverse x is just y, we can write this as sine of y equals x. Okay? So next thing we're going to do is we're going to take the derivative of both sides. So d dx, and of this side as well. So this we have to use implicit differentiation for. So that was, I think, 2 videos ago. So you can go back to that video if you need a refresher on implicit differentiation. But I'm just going to do that right here. So this is just going to be equal to cosine of y times dy dx. And then the derivative of x is just going to be 1, right? So the main thing we want to find is this thing right here, dy dx, because that corresponds to the derivative of this, right? So literally what we want to find is dy dx. So let's do that. So what we can do, we can divide both sides by cosine y. So dy dx equals 1 divided by cosine of y. And now we're going to do something a little strange. We're going to say that cosine y is the same thing as the square root of cosine squared y, right? And this is true because the square root and the square are just going to cancel out. So cosine y and square root cosine squared y are the same thing. And here's why I did that. Ready? So now what we can do, we can use our Pythagorean identity to tell us that cosine squared y is the same thing as 1 minus sine squared y. Remember? Because we have the Pythagorean identity of sine squared x plus cosine squared x equals 1, right? So cosine squared x would just be 1 minus sine squared x. Fair enough? So what we're going to do, we're going to substitute that in. So we're going to have square root 1 over square root 1 minus sine squared y. Okay? Now, we remember what sine y is, right? Sine y is just x. So then sine squared y is just going to be x squared. So this is just going to become 1 over 1 minus x squared. X squared. Pretty easy. So, in other words, the derivative of sine inverse x is equal to 1 over square root 1 minus x squared. Right there. Now if we want to do the same thing with cosine, it's pretty much the same process. So I'm just going to erase this. Let's do the same thing with cosine. Ready? So first thing we're going to do, y equals cosine inverse of x. Right? And this is the same thing as saying cosine of y equals x, right? This is the same thing that we did last time. So same thing, we're going to take the derivative of both sides. So and implicit differentiation again is going to give us negative sine y times dy dx equals 1. Okay? So now we want to solve for dy dx. So dy dx equals negative 1 over sine y. Negative 1 over sine y. I'm going to do the same thing, right? I'm going to do negative 1 over the square root of sine squared y. Sine y and the square root of sine squared y are just the same thing because the square and square roots cancel out. We did the same thing for sine inverse of x as well. So now sine squared of y is the same thing as 1 minus cosine squared of y, as we showed from the Pythagorean identities, right? So dy dx equals negative 1 over square root 1 minus cosine squared y. And same thing up here. We saw that cosine y is just x, so then cosine squared y is just going to be x squared. So substituting that in, we get dy over dx equals negative 1 over square root 1 minus x squared. And this looks extremely similar to the sine inverse one, right? So we see a pattern right here. Since the derivative of sine inverse x, as we just found, was of sine inverse x, we found was 1 over square root 1 minus x squared. Cosine inverse x is the same thing, just negative, right? The only thing that's different is the sign. So cosine, the only difference in this was that this is negative, right? So I don't know, that's pretty cool, and it's kind of like also a good way of memorizing it, that these two are the same thing except the sign's just different, okay? Okay, now tangent is a little bit more complicated. So let's do that. So we're going to start with the same thing. Wait, I'm just going to switch markers. Okay. So tangent inverse y equals, y equals tangent inverse x, right? And then we're going to do the same thing we've been doing. We'll get tangent of y equals x, right? And same thing, we're just going to take the derivative of both sides. So over here, we're going to get, so derivative of tangent is going to be secant squared. So secant squared y, and we're going to have times dy dx. And then the derivative of x is just going to be 1, right? So we know secant squared y is just 1 over cosine squared y. So, and then if we multiply that over, we'll just have cosine squared y on this side. So we'll have dy dx equals cosine squared y. Y, not x. Okay? So this looks pretty simple, but again, I'm going to do something kind of crazy. So I'm going to do cosine squared y divided by sine squared y plus cosine squared y. And the reason I can do this is because sine squared y plus cosine squared y just equals 1, right? So this is effectively the same thing as dividing by 1. So these two things are going to be equal. So now another thing I can do is multiply the numerator and the denominator by 1 over cosine squared y. And I can always do this. I can always multiply the numerator and denominator by the same thing, because that's the same thing as multiplying by 1. So I'm going to do cosine squared y divided by sine squared y plus cosine squared y. And then multiply that by 1 over cosine squared y divided by 1 over cosine squared y. Now, I know this is a bit confusing, but just wait. So this and this is going to cancel out, and on the top we'll just be left with a 1, okay? And then on the bottom, we're going to have sine squared y divided by cosine squared y. So sine squared y divided by cosine squared y. And then plus cosine squared y divided by cosine squared y. Now, we can simplify this. So we'll still have 1 on the top. Sine squared y divided by cosine squared y is just tangent squared y, right? So tangent squared y. And then cosine squared y divided by cosine squared y is just 1. But wait, we know what tangent y is. We found it right here. Tangent y is just x. So then tangent squared y is going to be x squared, right? So then we'll be left with 1 over x squared plus 1. And the more kind of normal way of writing this is the same thing, just 1 over 1 plus x squared. This is the more normal way of writing it, but yeah. Okay, so I have all 3 formulas that we just found up here on the board. You have 2 options. You can either choose to memorize these formulas, or you can choose to derive them every single time like I just did. I would recommend memorizing them because it's a lot less time consuming. Honestly, you saw how long it takes to derive each formula. So it would just be a lot easier if you memorize them, but obviously if you want to derive them, that's fine too. I just think memorizing them will save you a lot more time whenever you have to deal with problems dealing with inverse trig functions. So yeah, you can look at these. Honestly, I feel like if you had to memorize any one of them, I would recommend memorizing the inverse tangent formula, my bad. Because first of all, it's probably the easiest one to memorize, and it's also the most used in calculus. This is the one that we kind of use the most whenever doing derivatives or anything. So that's going to be all for this video. I hope you found it helpful, and as always, if you have any feedback for me, please let me know in the comments so I can make better content. If not, I'll see you for the next video. Bye bye.